Welcome, my dear students in Prep 2. Our session today is about intervals. Okay, before we start talking about intervals, let's see this example. For example, here we can represent a subset of the integers by different ways. Let's take the set of integers which are greater than or equals to -5 and at the same time less than 1. Okay, the first method is description method. I can write this subset using description method x a such that a belongs to z integers and a greater than or equal -5 and less than 1. This is the first method. Or using the listing method, I can write all the integers which are greater than or equal to -5 and less than 1. -5, -4, -3, -2, -1, and 0. Also, we can represent this subset on the number line, like here, as a separate point. Okay. What about if we have a subset of the real numbers? For example, if x is a subset of the real number, x I will take the same example. X is the set of the real numbers, but here real, not integers, are greater than or equal to -5 and less than 1. We can use the description method. Yes, we can. X equals a such that a belongs to r. Instead of z, we write r because here the real numbers. A greater than or equal -5 and less than 1. Okay, can we use the listing method? Of course we can't, because we have infinite numbers between each two whole numbers in the real number. Okay, so here we can't use the listing method. Also, we can't represent this set using a separate point on the number line. So we will use another method which is called the intervals. X equals a such that a belongs to r and a greater than or equal -5 and less than 1. Okay, this is an interval. I write the smaller than the greater, so -5, comma 1. Then if we have or equal, it means that -5 belongs to this set. So I'll close this bracket, square bracket. Here we don't have or equal, so 1 doesn't belong to x. So I open the brackets. Okay, so that it means what? This interval means -5 and all the real numbers between -5 and 1 only, but 1 doesn't belong to x. Can we represent this interval on the number line? Okay, yes. I'll start with -5. -5 here, closed. So I'll draw a closed circle like this. 1 open, so I'll draw open circle. Now, where is the intervals? All this zone is the interval, -5 and all the real numbers between -5 and 1. Okay, we have different types of intervals. We have limited intervals and unlimited intervals. The limited intervals can be closed, opened, or half opened. This table will clarify the types of intervals. We have two real numbers, a and b. A is less than b. The first type of intervals is the limited intervals. Let's take, for example, the closed interval. Closed interval means closed at a and at b. Can we write it as using the description method? Yes. X greater than or equal a and less than or equal b. Can we represent it on the number line? Yes. I'll draw closed circle A, closed circle B, and this is the interval. Also, it can be opened, like here, A and B, open interval. By the same way, I can write it using the description method, but without or equal, because here A and B doesn't belong. So, x greater than A and less than B. And also that means the two circles will be open. Half opened or half closed, the same meaning. Like here, for example, opened at B, so there is no or equal here at B. It means closed circle at A, open circle at B, and this is the interval. Or opened at A, like here, so there is no or equal at A, but here we have or equal. So opened at A, closed at B, and this is the interval. What about the unlimited intervals? Unlimited interval, we will use in the description method only one inequality sign. Also, we will have infinity or negative infinity. Let's take an example. Here, for example, from A to infinity, what does it mean? It means that the smaller is A and there is no greater real number to infinity. So I write that x greater than or equal to A. So closed at A and all the real numbers greater than A. Another one, opened at A, so also all the numbers which are greater than only, greater than A, like here. So opened at A, and all the digits to the right, all the real numbers to the right. Okay. Or like here, for example, we have negative infinity. At infinity or negative infinity, it should be opened. Okay, because infinity and negative infinity are not a certain real numbers. Okay. Here from negative infinity to A, it means A and all the numbers, the real numbers, less than A. So like here, x is less than or equal A, 2. So here, yes, closed circle and all the numbers to the left. By the same way, from negative infinity to A, open at A, so open circle at A, and we will write only x is less than A. Okay, so we have two types of intervals, limited and unlimited. The limited can be closed, open, or half open. The unlimited, we will use only one inequality sign, and we will have infinity or negative infinity. Let's take a small example here. Write each of the following in in interval form, then represent them on the number line. The first one, x is greater than or equal negative 5 and less than or equal 3. It means, what is the smallest number? Negative 5. The greatest? 3. So I write negative 5, comma 3, opened at negative 5 because we don't have or equal, closed at 3, like here. Okay, what about the number line? This is the number line. I write the two numbers, negative 5 and 3, only the two numbers. Don't write all the numbers in the number line. Opened at negative 5, so open circle. Closed at 3, so closed circle. This is the interval. Number 2, y such that y belongs to R, y greater than or equal to negative 6. So all the numbers, or the real numbers from negative 6 and to infinity. And here we have this. It means that the smallest is negative 6. So I write negative 6, comma, infinity. I'll close at negative 6 and open, of course, infinity always open. Okay, so from negative 6 to infinity. Okay, the number line, negative 6 is here, then all the numbers, the real numbers which are greater than negative 6. Okay, so this is the interval. That's all about our session today. We have another part of intervals next session. We will talk about operations on intervals. I hope you have understand our session today. Thank you very much for watching. See you next session. Goodbye.